Hello everyone, once again welcome to the course on manufacturing methods. In the last class already we have stated the objective of the subject and the syllabus as well as the COs are being discussed, and I have told you to buy some books. You may buy the P.N. Rao book, maybe Amitabh Ghosh and Malik books. Those are very good books. Maybe the Kalpakjian books. Okay, any books you may buy from maybe Amazon or Flipkart, or you can also search for the e-version or soft copy of those books also. Okay, so this thing, the introduction about manufacturing, why we need this, and what is the concept of manufacturing. Okay, what does it encompass, okay, from where it has come, and the various categories of broader categories of processing methods like casting, forming and shaping, machining, joining, finishing process, etc., or additive manufacturing or 3D printing. Those things already we have discussed. So in this particular course, as we have already discussed, that basically we will be dealing about the casting, forming and shaping, etc. So machining processes and those things already have discussed in previous semesters, manufacturing technology and all. And similarly, some advanced finishing processes, etc. also we'll be discussing. Also, we have discussed that there are various advanced or non-conventional manufacturing processes, rapid prototyping, and depending on what is the level at which you are working on, or you can say what is the material unit material removal at a particular level. So based on that, we also have different micro, meso, micro, nano manufacturing, etc. So the various materials in manufacturing, these things also we have covered. So I told you to go through some very interesting materials like shape memory alloys, SMA, some amorphous alloys like metallic glass or superconductor, etc. Or you can also go through the recent advances like ferromagnetic materials, etc. I told you to go through this, and I hope by this time all of you have already gone through it and you are being fascinated by the fascinating properties of this kind of new materials. So I told you that like these materials, various materials we can process maybe in solid or in its molten forms, that is liquid. Even CVD, there is chemical vapor deposition, you can consider that we are as if working on vapor form. Okay, so today we'll be basically going through one of the most versatile kind of manufacturing methods or process, that is casting. So what is basically casting? So casting, it's a manufacturing process in which molten metals, we work with the help of molten metals. So previously whatever metal we have, we melt it and we work with that particular molten version of this particular metal. And what basically happens, if we discuss in terms of your a particular definition, then we can define it like casting, it's a manufacturing process in which molten metal, it flows by means of gravity or maybe by from other source into a mold where it solidifies in the shape of the mold cavity. So mold, it's nothing but mold or mold cavity, it's nothing but kind of the hollow replica of the shape. Okay, it's a kind of hollow object, or you can say not the object but hollow shape, the shape of which, final shape of which basically we want. So there are certain basic steps involved in this particular casting process. So if we discuss about the steps in a sequential manner, then if we have to do the casting process, then at first our task will be to create the mold cavity. Okay, so creating the mold cavity means, that means suppose I want a spherical shape, then we must have a hollow sphere. Okay, a shape in the frame of a hollow sphere. Okay, next we have to melt the metal. Okay, so right now we are discussing about metal casting. It's possible to cast with some other polymer material also. Okay, but right now we are discussing about metal casting, that's why we have written melt the metal. Okay, so whatever is the processing metal, suppose if you want to work with cast iron, if you want to work with suppose aluminum or whatever is the metal, you have to initially melt the metal. So there are various ways available to melt the metal, different furnaces, etc. So you are going to melt the metal. Okay, and next step will be to carefully pour the metal into the molten metal into the mold cavity. Okay, so now with whatever molten metal you have, okay, with which you want to process. So that particular molten metal you are going to pour into the mold cavity. So for this there will be various stages like designing of all those mold cavity, the riser, etc. Okay, so but what you are going to do, you are going to pour the molten metal into the mold. After that, once the mold has been filled with the molten metal, you have to allow it to solidify or freeze. So right now, with the help of the word freeze, we don't mean like the freezing of the ice or that kind of thing. So it means that basically we are allowing the molten metal to solidify or to cool down. That's why the word freeze we use. Okay, both are having similar meaning in case of casting. Okay, we are allowing the liquid metal to solidify, or freeze means to cool down. So what is the meaning of this cool down? Basically, see, if we are talking about molten metal, so we already know almost all the most of the metals, they in their normal form they are in solid form. Okay, if we have to melt it, definitely we have to heat it. Only by heating we will be able to melt it, right? We have to go heat it beyond its melting point, and then it will be in the molten state. Now in the molten state, definitely it will be very hot. Okay, and once it is being poured in this particular cavity, we don't want that later on we need the final product in the solid form only. Okay, so in that particular case, if we need to have the solid product, so we have to allow it to solidify. Okay, the molten metal to solidify or to cool down, that is freeze. And at the end, what we'll do, once the freezing process or cooling process everything is being over, so depending on what kind of mold we have worked on, whether it was permanent mold or expandable mold, okay, that means whether we have to break down the mold or whether the same mold will be reused again and again. Based on that, we have to will be working and will take out that particular product, okay, final product. And last, if we'll be doing the inspection on it, okay, whether the proper desired properties has been achieved, whether the desired dimension has been achieved, if there is any fault and all, crack or some other marks, etc., whether product is acceptable or not, that kind of inspection we are going to do. And in most of the cases, in some of the cases, we have to go for some secondary finishing processes, okay, surface finishing processes, etc. Or sometimes we'll have the riser, so which are some extra part, so those part we have to cut it or chip it down, okay, and finally we are going to freeze it, we are going to finish it. Okay, so those are the main basic steps involved. So what are the steps that we have discussed? At first we have to create the mold cavity. Okay, with for creating the mold cavity, what are the things we have? So I hope by this time already from your previous knowledge you already know the words like pattern, okay, what is mold, what is core, okay, and what finally we call as cast. So still I am discussing it. So pattern, it's nothing but the replica of the final object to be made, but there may be certain modification. Okay, it's possible in most of the cases we have certain modification on it. Okay, so the pattern is something like solid thing. Okay, so it is kind of the replica of the final object. That means we already know what kind of object we want. That's why we know its dimension and all, we know the shape. Okay, so now for making the mold cavity, initially we have to have the pattern, and it's nothing but the replica of the final object to be made, but certain allowances, etc., sometimes some other parts, etc., being added in the pattern. Okay, some modification is possible. Next, if we call about the mold and the word core, what does it mean? So its mold is nothing but mold contains cavity whose geometry determines the part shape, that is the external surface of that final part. Okay, so that is what is mold. Now if suppose the final product contains some hollow part, okay, then what happen? Then you consider, suppose your plastic bottle, water bottle and all, okay, so this casting is something like as if you already have the bottle, okay, so inside of the bottle is kind of hollow, yes, and it has got certain shape, that shape is the shape of the bottle, correct? So now if you pour water to that particular bottle and fill the bottle with water, so basically, and after that suppose you are freezing it, okay, freezing it, that means you are entering it to the freezer, deep freezer and all, and you are making it solidify, that is ice. Then what will happen, the final shape of the ice that is being formed is it will conform to the geometry of that particular bottle, yes or no? So the casting is also kind of similar, that kind of thing only, okay. In itself, in layman's term, you can consider, you can correlate this with this casting with this particular object. Now in that particular case, see, once I fill up that particular bottle with water, okay, and finally I get the ice form, okay. So in that particular case it is not possible, that means I will have at the final stage only a solid part, yes or no, solid ice. But if I want, suppose there should be one hole in that particular whatever solid part that I have obtained, so in that particular case what I should do, so in that case this core helps, okay. So this word core, so what does it do, so if I need some hollow cavities in the parts final cast, I can say final cast or the final product, then we have to use some core with that particular whatever is the shape needed, hollow shape needed. So core, it is placed inside the mold cavity, okay, to define the internal surfaces of the casting. So sometimes if you need, suppose some hollow cavity, etc., maybe that kind of whatever is the hollow shape that you need in the casting, so that kind of core you are going to place inside the mold, okay. That means it will be something like, so it is something like, suppose if I finally need, suppose if I have this kind of hollow shape, suppose, so from this side, suppose if I insert the molten metal, okay. So if I pour it, okay, and if I fill the whole thing up, then at the end, once it gets solidified, okay, then I will have a product which will look something like this, okay. Now if I want a product which is, suppose, having this kind of feature, suppose final product is something like this, and suppose this part is hollow in the final product that I want, okay. So this is kind of hollow part, so in that case I have to use this kind of core, okay. So what I'll do in that particular case, if this is the product needed, this required, okay. So in that particular case, when I am making the mold cavity, suppose this is the mold cavity I am going to make, so then as this is the hollow part, okay, so I have to have a core whose shape is something like this. Now this is the core that I have to place, okay, that I have to place inside. And after this, if I pour the molten metal, pouring, if I do, so now what will happen, so this portion will get filled up, this portion will get filled up, and this hashed portion will not get filled up. So once, suppose I pour the molten metal, so it will not allow this particular portion to fill up, and only this portion will get filled up. And finally, once it is solidified, and if I break the mold, okay, if I take out the product will look like this with this hollow region, okay, because previously the core has not allowed this particular region to get filled up, okay. I hope you have understood. Now what is cast, the word cast, it is, cast is the part obtained after the casting process is over, or the whatever part we obtain used by this casting process is known as the cast. Okay, so casting is the process, understood? So this casting is the process and cast is the final product. And I want you to go through some different terms related to casting, like what is scope, what is track, what is cheek, what is parting length, sprue, riser, etc. etc. I hope you have already you already know some of the things. Okay. Next, the same thing, the flow chart of a typical foundry process. So now what is this foundry process? Foundry process is nothing but this particular casting shop. You can consider like that, the whole process involved in the casting, that is foundry. Okay, so now if I have the whole process, then at first what we have to do, we have to make the pattern. Okay, and using the pattern we are going to make the mold and the core. Okay, so that will be the initial step. Then another step, that will be initial design stage. Okay, next step will be we are going to metal melting and treatment that we are going to do. Okay, so definitely if we have to work with the metal, we have to initially melt the metal. Okay, then it will be our casting process, will be the main casting, that is the pouring metal into the molds, that will start. Okay, and then after the molding and metal melting and treatment is over, and we have poured the metal, molten metal into the mold, then separation of casting and mold. Okay, so that means after solidification, that is the step we have to go for. Okay, next after that, see, I have already discussed that there will be some runner, sprue, riser, etc. in that particular mold, which are something like extra thing. Okay, so those things we have to remove. Okay, next after once that is being done, we are having the final whatever is the desired shape we have. Okay, so after that we have to go for all those, you can say, like cleaning, etc., fettling, etc. Okay, and finally if required, then optional finishing processes, sometimes maybe some machining, some painting, etc., we have to do. And similarly in between, if we see that some problems are being associated, suppose removal of runner, riser, those are in that particular case, uh, those are kind of whatever we have removal of runner and riser, those are kind of excess kind of thing. Okay, and we can reuse them. Okay, so next we will be returning those extra material for recycling. Okay, once again we can, in the next run we can once again melt it and we can once again use it. Similarly in the previous process, that is separation of casting and mold, suppose if we are talking about sand casting, so we will break that particular that particular mold. Okay, and whatever sand, okay, casting sand it is available, that once again we can recover and reclaim, or reclaim means reuse. Okay, and once again we can, that can be used for mold and core making. Okay, so I hope you have understood the whole process. So in that particular case, if you can recall from your previous knowledge, so basically your runner, what I want you to go through, what is the use of this riser and all, and I hope already you know. So riser, in case of this riser, it just act like a reservoir. Okay, so those things later on we will also discuss. Okay, so now what are the capabilities or advantages, limitation? So with the help of this casting process, we can create complex path geometries. Okay, we can create both external as well as internal features. So in case of some of the casting processes, they are net shape and others are near net shape. Net shape means in the same go, in the single go, the final whatever is the desired product geometry we can obtain in a single go. Okay, that is the net shape manufacturing. Okay, so it's possible to get the final whatever is the required product in its exact dimension alone with the help of this casting process, provided carefully you consider carefully design the whole mold and all, and the process is carefully executed. Okay, so the a very last size part in a single piece we can manufacture. That is one of the advantage. And we can utilize materials that are difficult or uneconomical to process by other means, because in this particular case only we should be able to melt the metal, and whatever design of the uh, mold we make, as per that we can get the final product. So, and some of the casting processes, they are suitable for mass production. Next, some limitations. In terms of limitation, we can say that in terms of mechanical properties, sometimes casting is limited. Okay, so sometimes giving directional properties and all, it's not that much possible. Similarly, you can getting sharp corners, etc., it's a challenge. Okay, and poor dimensional accuracy and surface finish in some of the cases, like in case of sand casting. So finally we have to go for once again some finishing processes and all. Okay, that is one limitation. And as we are dealing with very hot metal, so safety hazard for workers. And as we are talking about melting the metal, dealing with hot metal and all. Okay, so environmentally also it is somewhat problematic. So some of the examples made by car. Okay, so very big parts like railway wheels, pipe, belts, very big statues, etc., are being made. In case of automatic vehicles, also various engine blocks, heads, etc., are being made. You can even make different small parts like delta crowns, jewelry, small statues, etc., and even like that means that is the possibility. That means very big parts, very small parts, everything can be made with the help of casting. And we can deal with ferrous material as well as non-ferrous material. So this particular slide shows various parts in a typical automobile which are being cast. Okay, cast part. So you can see a number of, like right from the front to the back, a number of parts are being made with the help of casting process. So these are some of the other examples, like this particular first one figure you can see a steel casing for a nuclear power plant. It's so big, one man is inside it, under it. Okay, so crankshaft, next figure shows crankshaft, engine block, etc. Okay, and similarly, like by the help of investment casting, some hip stem, okay, those are being made. Okay, it's a biomedical interior product. Okay, so basically there are two broader categories of casting process. One is the expandable mold process, next one is the permanent mold process. So expandable mold process, it uses an expandable mold which must be destroyed to remove the casting. Okay, that means they are not permanent type. Once you will be making the mold, okay, will be the process, casting process is over, then to take out that particular product you have to break that particular mold. Okay, in most of the cases sand casting, plaster, similar material, etc., those are the mold materials in case of expandable mold process. So permanent mold process, definitely the name itself suggests, it uses a permanent mold which can be reused for producing multiple parts using the same mold. Okay, we don't break it after the process is over, but there will be provision to open it and we will take out that particular cast. Okay, and generally it is made of metal. Some advantages and limitation. So more intricate geometries are possible with the help of expandable mold process. Okay, part shapes in permanent kind of mold process are limited by the need of opening the mold. Okay, so that's why in case of expandable mold process you can give intrinsic details. After that you have to just break. But in case of permanent process, as we are talking about having reusing it, we have to give provision for opening it, closing it, etc. So it is limited. Part intricity or complexity is somewhat limited. But permanent mold process, if we are talking about high rate production or high production rate, then high production volume, then these permanent mold processes are more economic because we can reuse the same cast again and again. So this figure, I think typical sand mold showing its different parts. I hope previously in your manufacturing technology already you have discussed this. Okay, so so I have shown these two figures. First figure, it's a kind of open one. Okay, generally it is not generally used. Okay, in the second figure it shows the different parts like the cope, that is the upper half, and the drag, which are being separated by the parting line. this one is the parting line. Okay, so parting line separates the mold into two halves. Upper half is cope and lower half is known as the drag. Okay, similarly we have the pouring cup through which we are going to pour the molten metal. We have the riser which act as a reservoir for the molten metal. Okay, so whenever what happens, what does it do? It acts as a reservoir means whenever there is this is the cast metal. Okay, this is the final shape suppose we want, and in that particular final shape if we wanted this kind of hollow shape, then we have to use this core, solid core, so as to get the final hollow shape. That blue kind of shape, blue colored shape, you are going to get later on after the process is over. Now if we are discussing about the riser. So this riser designing I have already in manufacturing technology have done. So still we are recalling it. So with the help of this riser, it acts as a reservoir for the molten metal. So when the solid when the liquid metal cools down, we already know liquid metal when it solidifies it will contract, that is the volume will decrease. So to compensate for those things, riser helps in compensating. Okay, that is one of the use of the riser. Next, there is a term getting ratio, which is very important from the competitive exam point of view. So getting ratio, it's nothing but the ratio of sprue area to the runner area to the ingot area. Okay, so generally for high quality steel casting, getting ratio 1:2:2 or 1:2:1.5 will produce casting which are nearly free from erosion, and it will minimize oxidation and will produce uniform flow of metal. Okay, now what is the importance of getting ratio? If you don't select these dimensions properly, suppose last point you can say that getting ratio of 1:4:4, it might even favor the formation of oxidation defect. So we already know scaling, oxidation, etc. we definitely don't want. These are some of the type of defects we don't want them to be there. Okay, so we have to carefully select the getting ratio. And this word getting ratio, what is the meaning of getting ratio? It is sprue area to the runner area to the ingot area. Don't get intimidated by sometimes in competitive exam it is being asked. Don't write sprue volume by runner volume by ingot volume. Not the by its ratio. Sprue volume area is to runner area is to ingot area. Okay, and don't mix them up. Okay, so that is what you should remember. And next, solidification of pure materials. This particular part we are going to discuss in the next class. How we'll see later on how what is the behavior of solidification in case of pure metals, and what is the behavior of solidification in case of alloys. So we are talking about metal casting. So metal, it may be kind of pure metal, it may be kind of alloys. Okay, so depending on our requirement we have to work with it. So what is the behavior of, we must be able to control, or we must have the knowledge of solidification behavior of that particular metal, how it is going to solidify, and what kind of properties we can expect of this particular type of metal. Okay, whatever is the type of metal we are working on. Okay, and that particular behavior we must know, what kind of grains we can expect, how it is going to develop. Okay, and what particular part will be having higher strength and all, and those kind of things we are going to discuss in the next class. So thank you for listening. So your task will be to already go through the parts. What are the different parts of this particular we can say cast. Okay, similarly what are the different terms, some extra different terms, you just go through those. What is riser, what is the use of this riser, once again you just go through what is runner, what is gate, why that seals are used. Okay, that will be your task. Okay, for the next. So thank you for listening.